In this video, we will be doing two examples, one in which we are given the equation of a hyperbola and asked to sketch its graph and find key characteristics like the vertices and the foci, and another when we are given those characteristics and asked to find the equation of the hyperbola from them. Here we are given the equation of a hyperbola and asked to find the vertices, the foci, the equations of the asymptotes, and sketch the hyperbola. Again, anytime you're asked to find vertices, foci, and equations of asymptotes, I actually recommend that you sketch the hyperbola first from its equation. You'll notice here, though, that the equation is not in the form we're used to. Let's start by using completing the square to change this equation into the form that we like. We can add 9 to both sides and factor out the coefficients of x squared and y squared from the x and y terms to help us get started. We're really completing the square twice, once with the x's and once with the y's. So when we add our b divided by 2 squared term here, we will have negative 6 divided by 2 squared, which is 9. And for the y's, 2 divided by 2, which is 1, squared, which is 1. Keep in mind, though, that we didn't actually add 9 here. We added 36 because this 9 is being multiplied by 4. So to keep our equation balanced, we need to add 36 on the right to correspond to this. And when we added 1 in this set of parentheses, we are actually taking away 9 from the equation because that is being multiplied by negative 9. So we need to take away 9 from the right-hand side to keep the equation balanced. Now we can factor. And simplify the right-hand side, and we're getting a little bit closer. Notice, however, though, that the right-hand side is not equal to 1 as we would expect for a hyperbola. To fix that, we divide both sides by 36 and simplify. 4 divided by 36 would reduce, and we would be left with x minus 3 squared over 9. 9 divided by 36 would also reduce and leave us y plus 1 squared over 4. And 36 divided by 36 equals 1. And finally, we have an equation of a hyperbola that we recognize. We are asked to find the vertices, the foci, and the equations of the asymptotes, as well as sketch this hyperbola. My recommendation is that we sketch the hyperbola first to help us organize our thoughts and get a picture of what this looks like. If we notice the minus 3 and the plus 1, here we know that the center of this hyperbola is going to be right 3 and down 1. So let's draw our axes accordingly. Putting our center at 3, negative 1, right there. Next thing to do is notice that this divided by 9, which is 3 squared, is going to tell us that the box is right and left of that center point, 3. And this 4 under the y term is 2 squared, which is going to tell us our box up and down from the center is 2. So let's draw our box. 1, 2, 3 to the right. 1, 2, 3 to the left. 1, 2 up. 1, 2 down. And it looks like my axis isn't quite big enough, but we can always extend it. We're just drawing a sketch here to help us organize our thoughts for now. Okay. Next, let's draw in our asymptotes, which we know goes through the corner of the box and the corners of the box. Then we can sketch in the hyperbola itself. If we know that our equation starts with our x term, we know that the vertices are on the sides of the box and the hyperbola opens right and left. We know the foci are going to be within the branches of the hyperbola. It's sometimes tough to label them because we haven't calculated yet how far away from the center they are, but sometimes it's just a good idea to plop them down for a visual. We know that the distance from the center to the corner of the box is the same as the distance from the center to either of those focus points. And calculating this is not difficult because the box helps us visualize a triangle. This triangle, in this case, from the center to the top of the box, we know to be 2, and from the center to the side of the box, we know to be 3. If we use the Pythagorean theorem, we find that this hypotenuse is the square root of 13, and that will help us calculate the coordinates of both foci. So we can start there. The foci have coordinates 3 plus the square root of 13, comma -1, because we were starting from the center, which had coordinate 3, -1, and we were moving to the right square root of 13. The other foci is 3 minus the square root of 13 to take us back here. So 3 minus the square root of 13, comma -1. The vertices are usually pretty plain to see on the sides of the boxes. So we have, in this case, 3 plus 3, which was 6, comma -1, and 3 minus 3, which is 0, comma -1. The asymptotes, going through the corners of the boxes, is handy because we can see from the triangle that we've already drawn the slope of this to be 2/3 and the slope of this to be -2/3. So our equations, y minus the y coordinate, which is -1, so y plus 1 equals 2/3 times x minus the x coordinate, which is 3. And the other y plus 1 equals -2/3 times x minus 3. In this example, we're given a couple of the characteristics of the hyperbola graph, namely the vertices and the foci, and asked to find an equation. Let's start by making a graph of what we know so far. Placing the vertices at 2, 0 and 2, 4, and the foci at 2, 5 and 2, -1, the first thing that you'll notice is that because hyperbolas are symmetric, we can find that the center is at 2, 2. Because we know the foci are inside the branches of the hyperbola, we know our hyperbola is going to open up and down. This, together with the center information, means we have a lot of what we need to start writing the equation of our hyperbola. We know that the y term is going to come first because it opens up and down, and being the center is at 2, 2, we know it's going to be y minus 2 squared divided by some term that corresponds to the stretch up and down from the center. Then minus x minus 2, again because the center is at 2, 2, divided by some term that corresponds to how much stretch has happened side to side from the center, equals 1. To figure out the values in the denominators of our equation, let's take a closer look at the box that we've been drawing. Don't worry about being too exact with this box, as you don't know how much it is, in this case, side to side. However, this is just a sketch to help us organize our thoughts. I'm going to draw in the asymptotes. And what we can start doing here is labeling what we know. We know from the center to the top is 2, but we don't know how much it is from the center to the side. We do, however, know how much it is from the center to the corner of the box, because that is the same as the amount from the center to either of the focus points. The center to the bottom focus point in this case is 3. It is the same to the top. This one's just a little clearer to draw on our picture, and that tells us that this hypotenuse is 3. Using the Pythagorean theorem, we would find that this missing side is the square root of 5, and we can use this information to finish out our equation. We know that the denominator under the y term would correspond to b squared, b being the vertical stretch. In our picture, b is 2, so we can replace b squared in this equation with 2 squared, which is 4. Underneath the x term is a squared. That's the side-to-side stretch. From the center to the outside is the square root of 5. So a is the square root of 5, meaning a squared is 5. And we now have a completed equation of a hyperbola.